We are going to start off the year by talking about how we actually collect data. And there's some very basic things we need to talk about to begin with. For example, the basic idea in all of statistics is the difference between a population and a sample. And so those are the two terms we need to start defining first. A population is the entire group of individuals that we want information about. The key here is that it's the people that we want information about, not necessarily the ones from which we can get information. So if I want to know information about everyone that lives in the state of Tennessee, then everyone that lives in the state of Tennessee is my population. The sample, however, is the part of the population from which we can actually collect data. And my handwriting will get better as these videos go along. I have to get back into the groove of things. Samples are what we work with most often. It is very, very hard to pick a population from which you can gather information about everyone in the population. So we work with samples, and we use information from samples to tell us information about the population. So one of the biggest things first is to make sure we can identify populations in samples. So for example, in this example, the student government at a high school surveys 100 of the students at the school to get their opinions about a change to the bell schedule. Which would be the population and which would be the sample? Okay, the population is who we want information about. What do we want to know here? And what we want to know is what the high school students think about the change to the bell schedule. So the population here would be all students at that particular high school. I'm not interested in what the students at another high school think, just at that high school. Okay, and so the sample would be the 100 students that we surveyed. Okay, now a great thing about these videos is that you can pause them whenever you want to. Now that we have done one example, a great idea might be to pause the video, try the second example on your own, and then press play and see if what I tell you is what the actual answer is. So, scroll down a little bit so that I have some more room with which to write. And hopefully you've paused it, looked at this on your own, and have an idea about what you think the population and the sample is. In this case, we are talking about cans of soda, and they select a sample of 10 cans from the production line every hour. Okay, every hour is kind of key here because since we're resampling every hour, they may be making changes depending on the results that they had. So the population is all cans that were produced that hour. Okay, and the sample, hopefully you said, were the 10 cans that were inspected. Okay, that's the difference between a population and a sample. Sampling is very important, and it's important that you know the difference between these two words and that you can pick out, yes, that is a population, and yes, that is a sample. Some people have problems with that, and make sure you just think about the population being who we want information about. I want information about the cans produced that hour, or I want information about the students in that school, or I want information about the senior class. Whatever you want information about, that tells you who your population is. Okay? There are ways to sample well. There are ways to sample badly. One of the biggest problems that occurs when you are sampling is that people pick what we call a convenience sample. A convenience sample is one where you choose people who are convenient to you. Okay, so for example, I am interested in knowing whether or not people oppose or support cuts to an athletic budget, and I'm at a football game. I decide to survey the people at the football game. That's a convenience sample. Okay, the problem with convenience samples such as those is that they produce unrepresentative results because they constantly over or underestimate the actual value you're looking for. So if I am at a football game and I say, do you oppose cuts to an athletic budget, I'm probably going to get a larger proportion of people who oppose it than I would if I just asked a true representative sample of everyone in the community. Okay? We call this bias. Bias is using methods that consistently get it wrong. They consistently over or underestimate the actual result. Okay, I will give you a hint here. This is a big AP tip, a humongous AP tip. You need to be able to tell the direction of bias. Okay, does it over underestimate it? Does it underestimate it? So for an example, the football one, it would have overestimated it. In other situations, it may under. Okay, but you need to be able to look at that, think it through, and say, okay, this one, the direction is overestimating, this direction of bias is underestimating. Another type of bad sampling method is called a voluntary response sample. We participate in voluntary response samples all the time. If you have ever watched or called into American Idol, or So You Think You Can Dance, or Dancing with the Stars, any of those type shows where you call in and vote, you are participating in a voluntary response sample. All that voluntary response sample means is that you get to choose whether or not you participate. And that doesn't mean someone asked you if you'd be willing to answer a few questions and you said no. They are choosing you, and whether you say no or yes is your right, but you were chosen for that sample. Voluntary response means you get to choose yourself. I'm going to choose to call in to So You Think You Can Dance, or I'm going to choose to call in to American Idol, or I'm going to choose to answer this poll that I found online. Okay, these are very bad methods of obtaining samples because people who choose to call in are only people who really have strong opinions. So it's also unrepresentative. Okay? Only people with strong opinions usually respond. And usually if they only have a strong opinion in the direction that they are unhappy with. For example, if someone was doing a survey, an online poll on a newspaper's website, and it said, do you think that the headquarters for the United Nations should be in another country? Okay? If you're happy with where it's at, you're probably not going to respond. Only people who really believe that it should be in a different country would respond. So it's going to cause bias because it's going to under or overestimate the actual result. We're actually in class going to look at an article that the article was written because a class of statistics students decided to mess with an online survey. And so they all decided together who they were going to choose in this online poll. They all went on and chose them. And then the newspaper actually published an article based on the results because this class went on and chose someone very out of the ordinary. So we're going to look at that in class. Okay, but first let's look at some examples of bad sampling. Okay, for this example, the Los Angeles City Council actually voted to ban most travel and contracts with the state of Arizona because they wanted to protest Arizona's new immigration enforcement law. So the LA Times conducted an online poll. Okay, whenever you see the words online poll, that right there tells you I'm looking at voluntary response. Okay, they asked if the city council was right to pass the boycott of Arizona. Okay, the results showed that 96% of these people in the sample said no. Does this result represent the opinion of all Los Angeles residents? That would be a no. Because people got to decide whether or not they were going to answer this poll. Those who really felt that the city council was wrong were the ones who probably logged on and completed the poll. So it would not represent the people who believe that the city council was right to pass this boycott. And you'll notice that we see 96% here voted no. So we can probably guess that the direction of this bias is that it overestimated the people who said no, and that there are actually more people than just 4% who say yes. Okay. If you will look on page 211, there are some questions for checking your understanding. Consider this a self-check portion of this video. If you look at these questions, okay, they ask what type of sampling or what type of sampling method does this describe. I would pause the video, look at those two questions, answer them, and then press play on the video to see if what you think is what I think. So press pause now. Look at these answers. The first one is actually a convenience sample. Because if they're just going to pick the oranges off the top of the bin, the farmer could actually hide bad oranges at the bottom of the bin. So it's not a good sampling method because the juice company is not getting a thorough look at what is in the bin. The second one was a voluntary response. And it actually is the question I had about the United Nations. So that is a voluntary response. And again, only people who really feel like the United Nations headquarters need to be moved are probably going to be the ones who respond. Okay, so that is bad sampling methods. The very best way to sample is to do something called random sampling. And the most common form of random sampling is what we call a simple random sample, or SRS for short. Okay, a simple random sample, what that means is that every sample from a population has an equal chance of being chosen. Every sample has an equal chance of being chosen. Okay, the easiest way to think about a simple random sample, the most basic way, and the way that works, anytime you have to do a simple random sample, you can most definitely use this method. We call this the hat method. You take your population, either number them and put the numbers on a piece of paper, or write the name of each individual on a separate sheet of paper, toss them all in a hat, mix them up, and pull them out one at a time. Okay? That's a simple random sample. It's the most basic way, and if you ever have to describe a simple random sample, describing it that way, writing everyone's name or on an equal size sheet of paper, mixing them up and pulling them out one at a time will give you full credit. Okay? It is not a simple random sample if you have to force it to be a certain way. For example, if we were in class and I needed 2 boys and 2 girls to do something, and so I split the piles, a pile of boy names and a pile of girl names, that is not a simple random sample because we don't have an equal chance of everyone being chosen. Okay? For it to be a simple random sample, everyone has to have an equal chance of being chosen. Okay. A great way to choose a simple random sample is to use a table of random digits. 2 properties that make it a good choice for creating a simple random sample. Each entry is equally likely to be any of the 10 digits from 0 to 9. So every digit is equally likely. And secondly, the entries are independent of one another. So getting a 1 first doesn't necessarily mean I'm not going to get a 1 later. So the entries are independent. Okay, we're going to look at what a simple random or what a table of random digits looks like in just a second. Some things that you need to know when you are using numbers, a table of random digits. I'm going to assign every person or everything in my population a number. All of those numbers have to be the same size. So I need to use, if there are 50 people in my population, 0, 1 to 50, and or two digits at a time. Okay, you need to know how to do this because it is very likely that on the AP test and on my test, you will be given a chunk of a random table of digits and asked to use it. Okay, something else that you need to know about tables of random digits or random sampling in general is that you need to decide when you are going to sample with replacement and without replacement. Basically, when am I going to use duplicates or not? If I'm sampling with replacement, that means that I could have the same thing twice. And without replacement, it means it cannot. And you just need to think through it and decide, can I have duplicates or not? Most of the time, we are going to be sampling without replacement, and when you get a duplicate, you would just need to say, this is a duplicate, I'm not going to use it because this thing has already been chosen and I don't want to sample the same thing twice. So now we're going to look at an actual example of how we use our table of random digits. And then we're going to use the table of random digits, and then we're also going to use the calculator. Some people prefer the calculator, some people prefer the table of random digits. You need to know how to do them both. So I am looking for 3 stores, a random sample of 3 stores to determine their hours they would like to stay open during the holiday season. Okay, here are all of my stores I have to choose from. So if I truly want a random sample, I'm not going to just look and say, okay, this one, this one, this one. I need a method. So I could cut them all apart, put them in a hat, and pull out 3. That's fine. The other thing I could do is I could go through here and number them. 0, 1, 0, 2, 0, 3, 0, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, notice that I started with 0, 1. You could even start with 0, 0, okay, and go 0, 0 through 2, 0, or 0, 1 through 21. Okay, it doesn't matter, since most of the time when we start counting with 1. That's usually where I start with. But the important thing to know is that I have two numbers here. So I'm going to pull up a table of random digits. In your book, it is in the very back, the last true page. It is called Table D. I have it right here. Okay, the problem said to use line 101. So this is what I'm starting with, right here. So I'm going to start with this first number, and I'm going to look at it 2 digits at a time. So the first one that I'm looking at is 19. Okay, for 19 here, okay, that was one of the numbers on our list. So whatever store 19 was, which I think was Star Jewelers, that would be the first one we sample. Okay, 22 is the next number. 22 was not on our list. We stopped at 21. Okay, then even though they're in groups of 5, I would look at the next 2 digits, 3 and 9. 39 is too big. 50 is too big. 34 is too big. Okay, 5 is on our list. So 5 would have been Carter's. $75 is too big, 62 is too big, 87 is too big, 13 is on our list. 13 would have been Mrs. Fields, and there we have our random sample of stores. Okay, what would have happened if I would have stumbled upon another 19 or another 5 or another 13? I would have just crossed it off because it was a duplicate, because I don't want to ask Star Jewelers twice what hours they want to be open. So crossed it off, ignore it, keep going. Okay, that's how you use a table of random digits. I have an Inspire calculator on my computer. Some of you may have the Inspire, some of you may have the Eddy 4. I'll show you on the Inspire. The commands are generally the same, just how you get to them is a little bit different. So in this case, on the Inspire, you're going to hit Menu, and you're going to go down to Probability, and then go over to Random, and then choose Random Integer. Okay, what you're going to enter in here is the first number, comma, the last number, comma, and how many of them you want. In this case, we want 1 at a time, and I'm just going to do this 3 times. So I'm just going to press enter. 20 would have been my first number, which would have been Vitamin World. Okay, I got a 20 again. I don't want a 20 again, so I'm just going to keep going. 4 would have been a second number, which would have been Barnes & Noble. And 11 would have been my third number, which would have been Hagar. And then I have my 3. The advantage to this over the random number table is that I don't have to worry about numbers that are outside of what I want. So it's going to go a little faster. Totally up to you which one you use, except sometimes you're going to be forced to use the random number table on tests and things like that. If you are using the 84, it's just as simple. The command for the 84, you're going to hit the math button. Okay, it's generally one of the colored buttons, or right underneath the second button. You're going to hit math. You're going to scroll over to the prob menu, and then there is a function, if you scroll down, that is called randint. When it brings it to the screen, you are going to put the same things in the parentheses. First number, last number, how many of them you want at a time. That's how you do a random number on either calculator. Don't forget, the first problem set that goes with this video are these 6 problems right here. Most of them are, what's the population, what's the sample, use the random number table, why is this a bad method of sampling, but those are the first 6 problems. And that's everything for day 1.